Stand by for broadcast.
You're listening to InsideAIR, a behind-the-wire view of the Royal Air Force, its people, technology and operations.
Hi, I'm Flight Lieutenant Chris Solly, and welcome to the latest RAF InsideAIR podcast. In this episode, we're talking about the next generation of aircraft to enter into service with the Royal Air Force.
This is a bold kind of comparison to make, but, you know, JFK gave the Apollo program 10 years to get to the moon. The complexity of the technology that we're bringing together and the products we're going to build, it is akin to that level of complexity. This aircraft is going to approach replacing Typhoon in a different way. So we're talking about the threat environment means that range has become a really big thing for all of us. And you see that's recognized everywhere. This is no surprise. So you look at the press around the American version of 6th Gen, so the next generation air dominance. You look at what we see in the threat nations. In all those cases, you can see range is becoming a factor. We're building an aircraft that is going to have an awful lot of range, but at the top of our list is the payload.
As usual, we'll also reheat a few stories which could have slipped under your radar, and we'll be finding out who's under the hat this week with AS1 Ben Russell.
What's your proudest moment in the RAF?
I'm really lucky. I've had a fair few, but I think whilst I didn't recognise it at the time, I did a tour in Afghanistan where I acted as the Casualty and Compassionates JNCO for Task Force Helmand out there, and the work that I did there and helped basically when people were in the worst circumstances is probably my proudest moment, if that makes sense.
Tempest, GCAP and FCAS. Want to know what it all means for the 6th generation of aircraft planned for service with the RAF? We'll be hearing from Leonardo, Rolls-Royce and the RAF itself as Sqn Ldr Peter Lisney gets an InsideAIR update.
Welcome to InsideAIR. It's very good to have you here, gentlemen. We're going to be talking about Tempest or FCAS or GCAP or Team Tempest. I don't really know. So that's going to be the first question. But before we get on to that, I'd be very grateful if you could introduce yourselves. And we'll start with you, sir.
Hi, I'm Group Captain Bill. I lead the requirement and concepting team for the UK MOD as part of the FCAS programme and with my trilateral GCAP partners in Italy and Japan.
Hi Peter, I'm Dave Morris. I'm Head of Campaigns for Future Combat Air for Leonardo UK. The campaigns role ensures that we're engaged with the customer at all times and that we're getting the message out there to the other stakeholders of why this is such an important programme.
Hello Peter, Mark Tivey from Rolls-Royce down in Bristol. I am the Business Development Director for the Future Programmes team down in Bristol. So we are looking after FCAS and GCAP, and we'll talk about that, I'm sure. But my role is principally to ensure we keep the programme sold. So much like Dave, working with stakeholders we have in UK government, interacting with our partners in Italy and Japan, and ensuring that we keep an eye on the commercial aspects of how we interact with the programme as well.
Great, thank you. So who's going to answer the question, what is Tempest, what is GCAP, what is FCAS?
Well, why don't I start and then we'll see if my industry colleagues agree with me. In part, it gives you an indication of how the programme began, its birthplace and its kind of route to today. So there's an awful lot in the names. The names tell you the story of how we got here. So I'll tell you where we are now, and then industry can fill in how we got there, because I think these guys were there for the journey. So FCAS, the Future Combat Air System, that describes the system of systems. So it's not just one solution that is going to replace Typhoon in the 2040s in order to provide the combat air capability we need in the UK to fulfil our defence roles. So we're acknowledging with that we're not looking for just a platform. We're not looking for just one type of platform or one type of solution in order to fill that capability gap. Within FCAS, you've got GCAP, the Global Combat Air Programme. Now that is a trilateral programme with Italy and Japan, and the aim of that is to deliver the core platform And I'm going to break out an American sporting metaphor here, and you're not going to like it. You're going to wish it was rugby or cricket or something, but I'm going with American football. So that core platform is a quarterback, and we like to think of it as a quarterback because it's the platform that walks onto the field knowing the plan. It understands what plans it has available to it. It's no longer able to maintain the connection back to the coach on the sidelines because you're too deep into the field. And the other players that are there in that team, some of those will be expendable. They will not make it through the play that we're executing. And that play will not go to plan either. And so the quarterback needs to have the ability, the strategic vision, and the reactions to be able to deal with what plays out when they start, and then pick how it's going to then deliver the tasks to what remains on the field, to look at what's going and then decide how it achieves the aim. Now, it's survivable enough to take a hit if needs be, so it's no kind of fragile back row player, and also if needs be, it can score the touchdown itself. But the aim here is that it's going to orchestrate many other parts. That system of systems.
That's the system you're talking about.
Yeah, that's the system we're talking about. So the GCAP, think of that as the organising centre of the system of systems that is FCAS. And we're building that GCAP right now. We're right in the heart of the development of that with Italy and Japan. Now, where Tempest and Team Tempest come from and those other parts, you have to go back a little bit in history. And it's probably a good point for my industry colleagues to chip in.
So Team Tempest was announced in 2018, I think, wasn't it?
Yeah,
Mark? 2018, announced at Farnborough Air Show, and it was put together between the K4 companies, my company Leonardo, Rolls-Royce, BAE Systems and MBDA, and the MOD to produce the technologies to develop the aircraft which will replace Typhoon in the 2040s. And hopefully, I imagine the aircraft will be called Tempest when it comes to the service of the RAF.
So it's a working title?
The
Tempest.
Tempest, yes. Yes. So Team Tempest is the UK programme. GCAP is the Trilac programme with Italy and Japan. And when the core platform comes into service, it, I would imagine, be called Tempest.
Oh, I don't know. We might have to have an argument about that as
Yeah.
well.
We'll see.
There's going to have to be a naming competition of some kind.
I've got £5 here.
So think of Team Tempest, or think of let's spool back one. Think of FCAS as like a connection network. So the aircraft that's flying along will be able to connect to space, to other air assets, to naval, to land forces, and be able to integrate the effect of all of those forces together. So that FCAS piece is not just other air assets, but it's its ability to connect and utilise other assets across all of the force network.
Okay, so yeah, it's a force.
GCAP is the core.
Yep.
GCAP is the core organising function within that system of systems that allows us to maintain a capability that is not. And the key point here is when we talk about replacing Typhoon, we're not like for like replacing Typhoon. So it's important to think about how the threat has changed from when Typhoon was envisaged and designed, from when F-35 was envisaged and designed and delivered, and for when GCAP is coming into service. So we're going to replace the roles, but we're not going to do it in the same way. Typhoon's a muscle car, yeah? It's designed to achieve its capability edge by accelerating faster, flying higher, putting more energy into its effectors, and by having sensors which are powerful, but you're not trying to hide. You're overt, you're a thug beating at the door of the enemy. And the way you win with Typhoon to take control of the air is you squeegee back the enemy so that you can then get to the thing you're trying to have the effect on or maintain the control of the air of the land or the maritime domain. GCAP is going to have to do that in a different way. And it's going to have to integrate with F-35 in a different way that Typhoon does. So we are replacing the roles of Typhoon. We're not doing it in the same way at all.
Okay. Could you ever see GCAP? Are we going to call it GCAP in this, or are we going to call it Tempest?
We'll call it GCAP.
Let's call it GCAP.
Okay, good.
Yeah.
I mean, yeah, I sound a little bit confused. I'm sure there's one or two listeners that might be a little bit confused too. So let's hopefully get to the bottom of this. Rolling back the clock, 10, 15 years, Afghanistan, Iraq, our fast air would deliver show of presence show of force. Do you think GCAP is ever going to deliver those effects?
So, and that's exactly why you have a mix. So remember, we're not planning for GCAP to be on its own as providing the combat air capability. It's going to be paired. It's designed to be complementary with F-35. So what we're looking to do is break down the tasks and the roles and the threats we're going to have in the future and say, what is F-35 going to provide? And what does GCAP need to provide? And what does the system of systems that they're within need to provide? So that show of force in the 2040s or 50s, F-35 is a fifth-gen aircraft that has stealth capability, but has still got performance around it and is designed for agility in a specific way. I mean, it's designed to land on a carrier. So it's got a range of abilities which are specific to it, and so it will fit that role well. There's no reason why a GCAP couldn't do a show of force, but the question is, would you want to use it that way?
It's going to be a beyond visual range aircraft, is that what you're saying?
I don't think that's the way that we'd characterise it and split it. It doesn't. I think the idea of defeating an enemy by turning harder, we have to ask ourselves if that's necessarily the way you want GCAP to fight. So it may be able to defeat a threat without needing to turn at all. Okay. And that's a really bold statement to make, remember, because we made that statement once before in the 60s with Phantom, where we said manoeuvrability was no longer a thing and that missiles would be able to do the job and radars would be able to do the job. And that turned out to be the wrong assessment. And we had to go through a whole cycle to get ourselves back to a place where we understood how we were going to use combat air. So we're not making any of these kind of statements lightly. There's an awful lot of analysis that goes on behind it. But I wouldn't characterise GCAP as only a long-range platform at all. I wouldn't characterise it as something that can't do that kind of high-speed or fast jet type role. Yeah. It's just a question of, would you want to fight like that in the future?
And I think that giving the pilot or the operator the option is what GCAP is about. Because if you look at the FCAS system, if the aircraft detects with superior Leonardo sensors, obviously.
Thank you.
If the aircraft detects a threat, Bill's quite right. The aircraft could choose to take that threat out using its own capabilities. It might also be able to connect to a Type 45 destroyer 200 miles away and task it to take that threat out without revealing its location. So there is a different way in which this capability is being thought about.
It's integrated with your other force elements.
Correct.
Yeah.
This is something that's really struck me about this programme that is different than anything that's happened before, is that you're working together, you're sharing. Tell me about that. How's that going?
Do you want to take that? I'll take that quickly. That's come from the Team Tempest aspect, and that's another aspect that you asked us to sort of define. Dave mentioned that Team Tempest was stood up in 2018, and it was stood up by 5 partners. It was stood up by the MOD and by MBDA and Rolls-Royce and Leonardo and BAE Systems. And it was stood up to identify, develop and mature technologies to be ready to execute a program that we are now envisaging. And so that's a real difference to what we did, I think, in Tornado and Typhoon before. I wasn't around at that point, but we launched the aircraft, Tornado, Typhoon, and developed technology in parallel to produce the aircraft. So whenever there was a hiccup in the technology development path, that had an impact on the schedule for the aircraft. We've learned that lesson. And so Team Tempest enabled us to start a program with which the government invested in that technology, but also the companies invested in that technology. That's a complete different departure from what we've done in previous generations. But we have both co-invested in that technology to get it to a point where we are very confident around the technological solutions that we can develop and deploy over the coming decade. So a lot of work has gone into digital twins. So we've performed lots of experiments, lots of rig tests to validate digital models, which give us confidence that the technology works for the next phase.
And there's other ways in which this program is making us work together at an earlier stage and in a different way. So requirements development can be quite a transactional or even confrontational activity in traditional programs. What we've done with this program is that we are sat down with our trilateral partners on the MOD side, so my opposite numbers from JMOD and from the Italian Air Force, and with industry, but it's all three nations industries, and we sit down together and we are generating those requirements together so we can fast iterate them in a way that avoids the throwing over the fence of the requirements to one side and industry looking at them and trying to understand them, but also wondering whether or not we realised that this was schedule or cost driving. So to behold this activity when it happens, because of course it's all happening at a very high classification, so it's all face-to-face for the time being, and you've got 250, 300 people, a mixture of nations and industry and MODs together in a room, working together, the kind of threads of teams. We call them threads. You might have 6, 7. In the early days, it was only 3. We're now up to 10, 11 threads of activity happening at the same time in these large open plan secure spaces as we work through this activity to build the requirements and develop the solutions to those requirements and understand how we're going to bring that together and integrate it. It's a deeply impressive thing. It makes me incredibly proud and also quite hopeful that we can achieve the ambition of this program, because it is very, very ambitious.
And the technologies that we're working on, this is highly specialised, cutting edge, absolutely cutting edge technologies. Our companies are very specialised companies and we have a vast amount of experience. I mean, ever since there have been aeroplanes, Rolls-Royce have been putting engines in them. Ever since there have been radars, we've been putting them onto aeroplanes. You know, BAE Systems, their forwarders, have been making aeroplanes for a very long time. The Royal Air Force have been flying aeroplanes very, very well for well over 100 years now. This is very, very different to the way we're doing this programme. Previously, we built aeroplanes and we put stuff on them, we've hung kit on it, and we've sort of made it work. You can't do that with a 6th generation aeroplane. Everything has got to be designed into it right from the get-go. The power and propulsion, it's doing an awful lot more than pushing air out the back to make the aeroplane go forward. There's a huge draw of power from the sensors that we're making, and you can't just throw antenna arrays onto this platform and expect them to work and the aircraft to be low observable. So all of that, we all have to work very, very closely together. We could not do it alone. And especially now we're working with our international partners.
And that's actually true with the international partners as well. You know, what is brought from Italy and is brought from Japan as well, both of them in themselves proud aviation nations, manufacturing nations. And if you look at, people often ask me, it's an odd pairing, isn't it? Or odd grouping, Japan, Italy and the UK. But let's break it down a little bit. We're all F-35 nations. We all like to manufacture our own capability. That's increasingly rare in the world now. There's a lot of fallen by the wayside. And we all operate a principle of a two-fleet combat air mix. In that we're always looking to, as one of our aircraft goes out of service, to replace it with another generation and then leapfrog over. So we have that diversity within that fleet mix. So that basic construct actually means that the pairing's been pretty straightforward. And I came from a long background in Typhoon where we had 4 partner nations. And I absolutely see when it runs well, a partnership like that, like Typhoon or like GCAP, when it runs well, it is a powerful thing.
We've talked about industry here at the prime level, but tell me about the opportunities and development opportunities for UK SMEs, small to medium enterprises, the smaller manufacturers that the primes could not work without.
Well, let's start with some facts first. So the number of people that are going to be employed, that are already employed by GCAP, so we're already into the thousands. And that will become tens of thousands as we build up to full scale. And the trickle-down effect of that is really significant. So I think it's something like 95% of the investment and work is happening outside of London and the South East that is coming from the programme right now. We've already got billions of pounds of investment that has gone into research. And as already mentioned earlier, that was matched by hundreds of millions of pounds that came in from the original Team Tempest industry partners.
Yeah.
And so that has already seen a recovery in the demographic of our subject matter experts and the small and medium industries, because that investment, as it's rolled down, has pulled from universities, it's pulled from research. And so a workforce that had delivered the last generation of aircraft that was all now approaching a certain stage in its demographic has been re-energized by this investment that's coming in at the bottom. So we're prepping ourselves not just to build GCAP, but it benefits current programs like Typhoon. And it also will mean that we have a demographic in place that can support subsequent generations, 7th gen, but also opportunities that spin off from GCAP, like autonomous combat platforms and all the other technologies, civil sector as well. So in Rolls-Royce, there's a significant field across to civil sector.
Yeah, and even just outside of Rolls-Royce. So Bill mentioned that the enterprise has been working with a lot of universities. I think the last count we had was something like 25 different university technology collaborations that we have across the country in all 4 countries of the United Kingdom. So, Northern Ireland and Scotland, Wales and England. We've spent, I think, Rolls-Royce, the last count, Rolls-Royce has invested somewhere in the region of about 17 or 18 million pounds directly into those universities to support that technology development. So the spill out is pretty widespread. And I'll give you a good example that we've just advertised, in fact, which we call Tornado to Tempest. We've worked very closely with an SME to develop technologies where we've recycled a titanium compressor blade from the RB199 engine that powered Tornado. We've actually atomized the titanium in that blade and reprinted it to be the nose cone of what we call our Orpheus demonstrator engine, which is a small low thrust engine, which is also part of the technology infrastructure for FCAS, not GCAP, but FCAS. And we've just done that. And we've just done that in very close collaboration with an SME partner, which highlights things like resilience in the supply chain. So we've got a lot of these blades from scrap that we can't make use of, but if we can recycle them, that gives the UK a supply chain resilience that we didn't previously have.
There are thousands of really specialist SME small companies in this country, and we've always drawn on that expertise. And is it worth a company like ours, like Leonardo, investing in doing a certain amount of work? No, because there are other companies we can use. And so traditionally we've done that. Now we see that because of the way the technology is developing and other technologies developing outside of the sort of traditional defence market. Example from the domain that I'm working with Leonardo, the sensors, the integrated sensors and non-kinetic effects. We will be generating vast amounts of data from the sensors that we're putting onto this platform, far too much than anyone could deal with. So the artificial intelligence industry, this is a marketplace for small startups and, groups of people coming out of university starting up. This gives them an opportunity to flex their muscles, as it were, and us to exploit that emerging technology now. That's just an example, because that's going to be huge going forward.
And is this linking into the defence industrial strategy from the United Kingdom?
Fundamentally, I mean, it is the pillars of our combat air strategy and then the aims of the FCAS programme, they all tie exactly back into that defence industrial strategy. It's a really important part. And if we get it right, there's no conflict with that in my mind. So my whole role is to deliver capability, and that is my purpose. But if I get this right, then prosperity naturally flows with that. Because if I'm really looking at capability in the round, then I want to ensure that I'm considering sovereignty and also supply chains. Well, we've just talked about how if we get it right, that reinforces itself. The partnership that we're achieving with GCAP in terms of the trilateral partnership, that's really important because that strengthens, that ensures security for the UK by making ties with other nations. And so there's an element to this that in every aspect, if we do this right, we will be increasing security for the UK in every way, and also increasing prosperity for the UK. Because if we make a good product, it's going to sell. And so you then bring yourself onto the principle of export, and the platform is designed to be exportable. It's designed to be open to other partners. So if we've got a good product that meets my capability requirements, it will also be an enticing prospect for sales.
It's a great point, because BAE Systems are what we term the lead system integrator on this program.
Along with MHI.
Along with MHI and with Leonardo in Italy. But those lead system integrators are working very closely together. BAE Systems looked at the impact of this program of GCAP, not FCAS, but GCAP specifically, on the UK. And if the funding were available to move the program forward. They worked very closely with PwC, one of the big four in London, to understand the economics of it. They've come back and concluded that if the program just went ahead on a national basis, so excluding the export that Bill referred to, the program would be a net positive contribution to UK GDP of somewhere in the region of about £37 billion. Now, you overlay the export success that you see we've had with Typhoon and that we hope to have with GCAP, and it's multiples of that to the UK. So this first and foremost has to be a capability that the RAF need, and first and foremost, it's about securing the security of our country. But there's no reason why this can't be a commercially beneficial deal for the United Kingdom as well. Typhoon has been remarkable. 70% of UK defence exports over the last decade have come from combat air, primarily Hawk and Typhoon.
So, but let me just sanity check something. As I understand, it's going to be 10 years or so before we see Tempest brought into service. So isn't that a long time to wait for a return on investment?
This is a bold kind of comparison to make, but, JFK gave the Apollo program 10 years to get to the moon. The complexity of the technology that we're bringing together and the products we're going to build, it is akin to that level of complexity. It's a hugely challenging technical endeavor that requires all these different disciplines to come together to roll out at the end of it something that is a capability. And so 10 years is actually, in development terms, that's pretty racy. I am definitely feeling the pressure. Now, it's also a huge privilege, but we have set ourselves an ambitious challenge. If we make that mark, it will be hugely impressive and a testament to the kind of engineering organisations from the LSIs and all of the Team Tempest industries in the UK.
Now, I'm really pleased you brought up NASA because the space programme, everyone thinks of aluminium foil, Velcro, some of those everyday products that are spin-outs from NASA. So what capabilities do you believe are going to be spun out of GCAP before 10 years, within the next 10 years?
Well, let's go back a little bit first and then look at how that's already happening. We're already seeing that. So in Leonardo Edinburgh, they're just in the process of integrating and starting to fly the ECRS Mark II multifunction array in the front of Typhoon. So that is, it's not a radar, it's a multifunction array, and that's going to extend the capability of Typhoon and its relevance. So a 4th gen platform flying in a 5th gen world, but that 4th gen platform in a 5th gen world is going to be enabled by the capabilities which are going to be in the ECRS Mark II. And it's also going to support and complement the F-35, because that pairing together of that Typhoon Thug with that F-35 Assassin is the same pairing you see on the deck of a US Navy carrier with a Growler and an F-35. But the key point about that is that not only do we have a next generation sensor being built in ECRS Mark II that's going to go into the front of the UK Typhoons, but it's also reconstituted the workforce within Leonardo. So they've gone through the process of designing and developing something that's right at the cutting edge, I mean genuinely at the cutting edge, and then critically they're going through manufacturing and they're taking it into service, and they're going through all the in-service lessons and spirals. So a TDP is great. TDP? Technology Demonstrator Program. So they have been vital to keeping some of the technologies and industries in the right place to be ready for this. But they're a bit like a Mars bar to a starving man. They're a sugar rush, but they're not broadband nutrients. What we've done with ECRS Mark II is you get that broadband development. That workforce now is going to enable us to build the sensor that's going to go into GCAP more quickly, more cheaply, with less risk, with better outcomes. And so it's the people that are the benefit. And so what I'm going to tell you is that what is GCAP going to give us? It's going to give us a workforce. The most important thing we can get out of it. It's going to give us an air force that is 6th gen aware and has gone through the process of bringing that aircraft into service and using it. And it's going to give us an industry across all the different industries, the LSI, LSSI, so the subsystem integrator, yep, and all those smaller and medium enterprises. They're all going to be reset for another generation. That is a huge legacy to deliver.
Okay.
You've stolen some of my sandwiches there, Bill, but thanks for bringing it up. ECRS Mark II is obviously very important to my company and to the Typhoon force, and it's a big step forward with Typhoon. What we're moving on to with GCAP, with the MRFS, the multi-role RF system, or radio frequency system, is the next generation again, and that's a massive leap forward in technology. But as importantly, the way we're making ECRS2 is helping us make MRFS and the systems that are going into GCAP. But the young guys and girls we've got now on our apprentice schemes and our grad schemes up in Edinburgh and in Luton and elsewhere as well, the guys and girls who are pulling out of school and university now and working on this program, they're going to be running this program in a few years on GCAP. So it's hugely important that they are immersed in that now, and we are building up our pool of talent and skills for the future. It's really a really important step.
I was thinking about that as you were both speaking, that our listeners from within the Royal Air Force that are new in their careers, an AS1 at the moment who's there'll probably be a sergeant or a chief tech servicing, leading teams to service these aircraft when they come in. The air cadets that are listening to this podcast, they'll be flying Tempest.
Yeah, that's right.
Yeah. And so you'll be sat in your armchair talking about it to various publications, reflecting.
Probably have to write a book at some stage. There's actually another one from Rolls-Royce, which is a really interesting one, and I picked this up when we were briefing the other services over the last couple of days, because I've been doing a series of briefings over the last 2 days. Rolls-Royce remaining in the military power plant industry. That's not just important to the Royal Air Force, because, of course, the other service that use gas turbines is the Royal Navy. So what we're doing with gas turbines and our propulsion system on GCAP is going to ripple across not just the Air Force, but into the other services as well, and their technologies and their capabilities. Same is true in sensing and EW as well.
Data, information, data, and all that sort of.
So we definitely see that cross benefit.
Bill was mentioning TDPs there, technology demonstrator programs. We have a whole host of TDPs which are supporting the development of the power and propulsion system. Roughly 80% of those TDPs have some spillover benefit to our civil sector, to our civil aircraft sector. Just give you one example of that. So we're all very familiar with additive layer manufacturing, printing, 3D printing, that kind of thing. We're taking some of the technologies that are within that to create geometries, cooling geometries in the engine, which could not be manufactured any other way. That is setting the benchmark for cooling technology that will be incorporated into the next generation of civil aisle or civil aircraft engines, both single aisle and twin aisle. So it's very real for us. It's about a continuum. And I think often in the UK we tend to take for granted that we have this gas turbine technology. It's a technology that a lot of countries around the world are trying to develop. We take it for granted because we invented it. It was here with Sir Frank Whittle right at the very beginning. But it is a national asset, and it is really important that Rolls-Royce make the most of taking the technology and using that in a continuum to extend our competitive edge in the civil area and the business jet area as well.
Yeah. So when I was thinking about this opportunity to speak with you, one of the questions I had in my pocket was, why are you talking about Tempest today when it's years away before it's delivered? And even to the point of shouldn't you just be talking about it when you roll it out onto the runway for the first flight? But you're so ahead of the game. I'm starting to get a picture of why you're doing that. But let's come to Leonardo. Why is this important? Because you run a podcast, don't you? Is Future Horizons that talks about Tempest along with the rest of the team.
Yeah.
Why do you do that?
Why do we do the podcast?
Why do you do the podcast? Why do you talk about it?
To get the message out there that this is an important program. It's important to the company. It's important to our companies. It's important to the nation, to the Royal Air Force, to our allies as well. On so many levels. I mean, Bill obviously is the expert on the military requirement and the military capability, but for national value as well. In that we are creating resilience for the nation, creating jobs, and these are specialist, high-paid jobs that we're doing. So the podcast is, as Mark mentioned earlier, it's keeping the program sold, is making sure people understand and can ask the questions of why we're doing this, or how do I get involved in this? Let's say you're going to university. What do I study at university? I'd like to get into that game. What course should I study? Which university should I go to?
And it's about making it clear that this program is at full sprint now, and people don't realise that we are already flat out with thousands of people, and those thousands of people are going to grow to be tens of thousands of people. It is a huge endeavour, and the only way we get to 2035 is by being at full sprint now. And so you've got to keep the people coming in from the universities. We've got to keep the people coming into the Royal Air Force because they want to be involved. And in this, we've got to feed this machine in order to deliver the output that we're all aiming for. Otherwise, we leave a gap in our capability. If we don't make that mark, Japan, Italy and the UK have a gap in their capability as Typhoon reaches the end of its life.
And it's exciting stuff. I'm so glad I came today because Bill's given me two analogies with NASA and quarterbacks that I'm just shamelessly going to steal. But it is genuinely exciting. This is the first time we've done this for 40 years. It shows my age because I still look at Typhoon and think it's a modern, futuristic-looking fighter. But it's been 40 years since we started doing Typhoon in the same way that we're doing Tempest now. So the opportunity to come in at this point and to influence the future trajectory of this whole program is really quite exciting. And it's really quite interesting. So in Bristol, I think, we've got somewhere close to 1,000 people working on this program. I think it's about 3,500 people working across the UK on this. We're getting close to 1,000 people working on the program. Our average age has gone down by a decade in the last 3 years. So we are, the workforce that we're seeing, the workforce that is delivering this program is getting younger and younger. And that's quite exciting because that's also quite challenging as well in terms of, they're looking to us to make this a more sustainable program as well and to think about that from the outset of design, how we do things. So, we'll probably talk about how this is going to feel in the RF, but it's going to feel very different in terms of its operation. We're envisaging a world where the data that comes off the aircraft enables sort of proactive management of the aircraft, to the point where you can start to envisage 3D printing at the side of the aeroplane to replace parts. So you don't have to transport stuff.
That's really good.
way.
So let's go down that road. What is the 15-year-old who's going to be a pilot when she's 25 years old flying this? What will they expect? What can they expect that's different?
Okay, so let's try and unpack this and see how we go.
And then I'm going to ask you the same question. What can the engineer, what can the designer?
Yeah. So this aircraft is going to approach replacing Typhoon in a different way. So we're talking about the threat environment means that range has become a really big thing for all of us. And you see that's recognised everywhere. This is no surprise. So you look at the press around the American version of 6th Gen, so the next generation air dominance. You look at what we see in the threat nations. In all those cases, you can see range is becoming a factor. We're building an aircraft that is going to have an awful lot of range. But at the top of our list is the payload. Payload is what we're all about. In fact, in pure capability terms, I don't care how I get it there. It could be in the back of an A400 from a submarine from space. It just so happens that our analysis tells us the best way to get that payload there right now is in a fast jet. But the payload, now you'd expect weapons to be in there, so that's obvious. And boy, will we have weapons. So we're talking roughly double an F-35A's worth of payload. That's pretty significant. But now we're also talking about the sensors. The sensors are as important. Everywhere GCAP goes, it carves a picture of the world to support other military capabilities to be able to exploit that and use that. And so getting the sensors forward is as important as getting the weapons forward. And those sensors also mean that when we go deep into enemy territory and we may not be able to reach back to anyone else for help, there's no connection with the E7 in the future, that we still can complete what we call the kill chain. So the ability to find and fix something, to identify it, to engage it, and then work out how that engagement went. We can still do that within our platform or within our formation. And then the third bit of that payload, and this is a real new bit, this is a bit that we don't talk about we wouldn't have talked about when I joined the Air Force, is we're going to take the compute forward. I'm going to take the server rack forward. Because if you want low-cost autonomous systems, we all know from turning our iPhone on, that how much data you pull to use ChatGPT. Well, where's that server going to be if you're deep in enemy territory? So if you want low-cost autonomous systems, they need a server to back them up and they need sensors to back them up to make them capable. So that quarterback has a really important role now because you're carrying the sensors and the servers to be able to enable that system of systems that's forward in that contested area. Okay. So that's right at the top, our payload. But to get there, we've got to have range now. But an F-15E's got range. So we also need survivability, which is the third corner of that triangle. And the survivability and our stealth, our signature, allows us to penetrate that airspace in a way that an F-15 can't. An F-15 or a Typhoon, they're thug platforms. They have to squeegee back the threat, whereas we can slide through it. So even if we have to leave the tanker a long way behind, the range we're talking about, and we're talking really extreme range, kind of maybe getting across the Atlantic to America on internal fuel, whereas a Typhoon is, 3 or 4 plugs to get across. With a payload, with the sensors, with the compute, but able to do it in a survivable way, that triangle, those 3 corners, that's the platform we're building, a platform that's got a huge amount of capability. Now, what you might say is, for one operator? Well, you think about if you wanted to go abroad in the 90s, the amount of planning it took to get the ticket and get to the airport, getting the AA map out and working out which route you're going to take, having no idea what the traffic was going to do, getting to the airport, not knowing where you're going, currency changing. At the other end, you've got no idea how the train system works. I can tell you, going to Japan, if you don't speak Japanese, you need a smartphone to back that up. With a smartphone today, not only am I doing all those things probably with less than a day's planning, maybe even on the day, but I'm having a meeting while I'm on the way to the airport as well, and in the airport going through it. I'm doing work while I'm on the plane, and I'm coming off the other side like some kind of Jason Bourne moving through the airport because your smartphone's planned it out all for you. I do a huge amount more with less effort in a smaller space of time. And it's not unreasonable to say that we can do the same thing with the systems in a GCAP. We can enable that 25-year-old girl you talked about, who's going to be the operator, so that they will be managing a huge amount of tasks coming in for a very large number of assets, but it's not going to require a superhuman. It's just going to require normal people that we can train in a normal amount of time who are willing to commit themselves to becoming a specialist. It's
So
entirely reasonable.
Are they going to be a pilot or a systems analyst? And is the pilot going to be sat in a container somewhere?
So
flying remotely?
Well, they definitely won't be remote, and I'll explain that why in a second. But with apologies to my Italian opposite number, because he will not thank me for this, I think we're talking about a single-seat Wizzo, not a single-seat pilot.
Glad you've said that.
And I say that as a pilot.
Right, okay.
That's probably going to immediately spike. Well, I'm going to get some
navigator. I'm going to quote you on that, Bill.
I'm going to get some hate mail from that one.
But there's a lot of love in this room right now, isn't there?
Exactly. There's some. Well, so coming back to the inner cabin, I just talked about how deep this aircraft's going to penetrate. So the idea of us being able to guarantee a connection back to outside. That's not reasonable. What I can guarantee is a connection back to the GCAP, that core platform. That's why I call it the quarterback. So we'll be able to maintain, we have to maintain a local network. In fact, I'm going to go back another step again. How do we fight as the allies in the West? Well, we know probably we're going to be outnumbered, yeah? And for a long time, we built a technological edge. And that technological edge allowed us to offset mass, so quality offsetting quantity. If that quality edge is eroded, our next step is it's our tempo, it's the speed with which we can go around our loop. And so in order for us to be greater than the sum of our parts, and that's a phrase we hold at the center of this. F-35 is a great example of this. F-35, when it's a formation, is greater than the sum of its parts. GCAP, but in some ways, that F-35 formation is a little bit selfish with the way it does that. With GCAP, 6th generation, where we're heading for is something that's greater than the sum of its parts, but that benefit is shared across the domains, so with maritime, with land, with space, and with other air assets. So it's our ability to connect which is going to be fundamental to our success. And when we're outside of the threat environment, we'll be connected in a very broad, low latency, high speed, high bandwidth way. And as we go in, we'll narrow that down and manage that for our survivability. But the key point is we're always in part connected, but you can't guarantee always that connection back, which is why right now, for the time being, we need a human in that quarterback position. We're prepared though for the time when artificial general intelligence does catch up. At the moment, large language models, I mean, they're just a stochastic parrot, yeah? They're advanced autocomplete. Even the reasoning models have got limitations, and they draw an awful lot of server space. I can't even begin to fit that in a platform.
So, I'm going to ask a question now, but you've sort of answered it a little bit, but let's get it out there. Fast air versus drone. One fast air unit could pay for 10,000 drones.
Yeah, and so, but then you've got to ask yourself, those drones have got to be able to penetrate that threat environment to a certain extent. If you're willing to lose a load of them, not so much, but they've certainly got to fly a long way. You probably don't want it to take 15 hours, so you want them to go a bit quicker. By the time you've made your long-range, high-speed, somewhat stealthy or completely expendable drone, you probably end up in a cost point which isn't necessarily where you'd expect. And so there's a balance. And there's a balance to this in all of it. If you want it to be low cost, you really want the sensors to be somewhere else. Maybe in a GCAP. If you want that compute to be somewhere else so they're smart and they're not dumb, you're going to need a server rack in the right place where you can connect to it without getting them killed, because talking too loud can get you killed in a modern threat environment. So you need a server rack there. Maybe that's GCAP as well. So there is absolutely a place for saturation through autonomous and expendable systems. That's definitely one of our 3 S's. Yeah. So we've got stealth, signature. We've got suppression, ECRS Mark II, the Growler. And we've got saturation. You do that, we've done that for years with weapons already, but drones are the new form of saturation. put those three things together and you've got yourself a really nice mix. But if you pick any one antibiotic and just overuse it, what do you breed? Antibiotic resistance. You get yourself whacked by something that's evolved to deal with you. So you need to have a spread.
The classic 1 + 1 = 3.
Yeah.
Okay. All right. So we talked about what it will be like potentially for the future pilot, operator, wizard. What about the future engineer that will be servicing, keeping this aircraft in the air?
I think it's going to be the young guys and girls now who are joining the service or at school who are looking to pursue a career in the Royal Air Force. We're going to be servicing these aeroplanes very, very differently. Not just day to day. I think Mark touched on earlier the 3D printing of parts next to the aircraft. That's very different. Also, we're never going to finish developing this aeroplane. Really, we're going to continually upgrade. We'll be spirally upgrading, certainly in the areas that my company are dealing with the sensors and the self-protection. Our potential adversaries will be scaling up the threat significantly, continually, very, very quickly, and we know that they're very good at that. We have to be better than them, so we need to spiral up our capability and the way we can defend ourselves and the effectors we're going to employ as well. So that will be a continual process of continually spiraling up, continually improving, continually developing, staying ahead of the game, ahead of the adversary. And our future aviators are going to have to be on top of this game as well. Not just with the physical nuts and bolts of maintaining an aeroplane, but making sure all the systems are ahead of the game as well. So that will be very, very different for the youngsters who are going to work on this aeroplane in the future.
Okay, thank you.
And that, I think, goes across the Royal Air Force and our compatriots in Japan and Italy. But it goes for the same for industry as well. And having that resilience in industry and utilising the digital backbone in order to be faster so that we can support the availability of the GCAP asset in service is in itself part of the deterrent effect. We don't want to fight wars, but this is about conventional deterrence, and GCAP is all about conventional deterrence, so that our adversaries know that we can hurt them. Being able to support that, having the resilience and the strength in depth in industry to do that, is part of the deterrent effect. So the future engineer in the Royal Air Force and the future engineer in industry will be working in lockstep.
And it's a really interesting point, because what I talked about with that triangle, those three things, that's one mission. Of course, you win a war, and Ukraine's shown us this in a way that we should never forget. It's the ability to go day after day, repeat mission after mission, week after week, month after month. And so with this platform, we're going to have to make sure that in striving for that capability that we need, that we want for the operator, that we make sure we make an aircraft that can be maintained and supported. And we're going to have to come up with new ways of doing that, because we're bringing technical challenges to that. Some of the systems we need, or the technologies we need, or the solutions we've come up with, they're going to present challenges to that maintainability and supportability. And it is absolutely vital that this platform has a small logistics tail, that it has the agility to play the shell game that will probably be needed in war, to move airfield to airfield, to use whatever fuel we find when we get there, to take whatever weapon we find in the stockpile. But we're going to need engineers who are equally able to go with that and enable us to turn that aircraft around in that timescale. Because if we can't do that, then one mission isn't enough. It's got to be able to go again and again. That's as much of an ask as any of the technical or operator challenges that we've discussed earlier on. And I have an opposite number within the team who is a complete mirror. He has a mirror team for requirements and concepting to ensure that we start thinking about that now, not later. It's not an afterthought. So something I didn't mention, and I think it's a really important point. When I started in Typhoon, all of the requirements managers were fast jet pilots. By the time we left Typhoon, that was no longer the case. We'd had our first engineer RM, and they were a huge success in terms of our ability to develop that aircraft. The team I have now within GCAP, there's only 3 out of 25 who are pilots. We've got people from the Waddington Force. We've got intelligence officers, police security, provost security, engineers. Then we've got a space force. We've got a mixture of people, and that diversity of thought means that we don't just approach this platform as a fast jet.
Yeah.
What I want to leave you with the idea is GCAP is more than just a fast jet.
And it's more than just a multi-role platform as well. It's going to be a simultaneous role platform. It's going to have to do different jobs at the same time in the same mission.
So if you're building something that's more than just a fast jet, you need more than just fast jet pilots to develop it and design it and build it. You need a mixture of skill sets. We're drawing from the whole Air Force. So I suppose one of the messages out of this is, if you think you're interested, it doesn't matter what branch or trade you're in, there's probably a slot for you within FCAS and GCAP.
Okay, thank you. Now, just to draw a close to this, our listener, when they think, this is interesting stuff, whether they want to follow a career in the Royal Air Force or follow a career Rolls-Royce, Leonardo, BAE Systems, MBDA, or academia, where should they look for more information about Tempest, GCAP?
Well, I think all of our organisations, including the RAF, have got dedicated GCAP, FCAS websites. They're a great gateway into not only what we are currently doing, but a gateway into finding people to talk to about developing careers. We're also very active in the university networks as well, highlighting what we do and providing career pathways. We have to compete. We have to compete with a lot of different industries.
But it's come across that you all sit on the same side of the table.
I don't mean competing between us. I mean competing with the HS2, competing with different industries.
Yeah. The automotive industry.
The automotive industry. But I think we are unique in doing something truly generational, and Bill talked about it earlier on. I love the Apollo analogy. We're doing something very special. We are really pushing the envelope in a way that other industries, I don't think, can either envisage. And we're attracting some of the brightest minds coming out of university as a result. And I think that's something we want to encourage and develop and continue.
If you want to see the model of Tempest, where can you see that?
Well, a great opportunity is at Reheat, so the Royal International Air Tattoo. Obviously, if you're an air cadet already, there's opportunity to go along with that, but anyone can go along to Reheat, and there's all kinds of stands and opportunities to engage with both the industries and the Royal Air Force in the different zones. But there's also STEM linkages there as well. So there's loads of different routes to get into Reheat, and at Reheat you'll find all of the people you've heard speaking today, but also all the other companies involved in Team Tempest represented, with loads of interesting things, loads of information available, and fun activities to kind of make this a bit of a richer picture. The other opportunity is the National Air and Space Camp, which happens at Sqn, and so that's another great opportunity to understand where the Air Force is going and the technologies which are going to be building that future Air Force.
That sounds brilliant.
It's a huge privilege. You get one go at this in a career, if you're lucky. So I came in at the back of Typhoon was already cast when I came into Typhoon, and so essentially you're just trying to fix the things you were given in that regard, and that was very satisfying. And then within it, you can make new stuff like ECS Mark II, but ultimately you're still working within the constraints. To genuinely have the blank sheet of paper, it's a huge responsibility, but a massive privilege. You get one go at this in a career normally.
Yeah. And so, do you still present at Sqn?
I do, yes.
Yeah, so we first met, I was on a course and you were talking about future capability. What sort of feedback are you getting from our junior officer cohort that attend Shrivenham for their continuing further development?
In terms of when we talk about this?
Yes.
Yeah, I think the number of people I've had who have said, look, can I be part of this? That's been really interesting because I'm not going to kid anyone. It's pretty full on. It is intense, but it's rewarding. And so I think the generation I briefed today at Shrivenham, they are really interesting in terms of their perspective. It's much broader than I think I was when I went through. And so they are also much more engaged in terms of understanding what value and influence they can have. And I think the pitch I would make is that genuinely within here, in a way that probably very few other jobs have, you have an opportunity in this program to have a really significant and long-term influence. And I think that for me is a feedback which I see for the junior officers I have in my team today. That seems to be the thing which motivates them the most.
Okay.
Yeah.
I'm going to give the final word to you, Dave.
Oh, my word.
The reason being is that you have a very long history in the Royal Air Force. Was it 1985?
85. I spent 22 years in the Air Force.
22 years in the Air Force.
I wasn't born then.
You were a backseat driver?
I was a Tornado GR1 and GR4 navigator, yeah.
Okay.
Yeah.
So you've seen...
I'm not sure any of my pilots I flew would refer to me as a backseat driver. But,
I think they would, actually.
maybe they would, Bill, yeah.
Okay, so you've seen a tremendous change in technology over the years. Do you want to sum up for us today?
I mean, yes. When I flew mainly the Tornado GR1 and the GR4, which I thought was a pretty technically advanced aeroplane at the time, and then that's gone out of service. Typhoon, I still think of as a new aeroplane because it was coming into service as I was leaving. I've now spent nearly 18 years in the defence industry. I'm immensely proud at this stage of my career. I'm going to retire in a couple of years to be involved and have the privilege to be involved in a programme like this. And this is such a step forward, both for the Royal Air Force, which I'm still obviously very, very proud, and I want to make sure that it gets the kit that our aviators deserve. But also for our nation as well, and for our allies, it's a huge boost to the economy, to build up our intellectual property, our resilience. So it's a massive step in the right direction, I think, and we need to keep the momentum going. But yes, hugely proud to be involved in it, and I'm loving some of the analogies that Bill's come up with. I'm going to use them as well. And the iPhone one, I'm going to use that at.
Yeah, they're all licensed. It's going to cost you.
Okay.
Well, Dave Morris, Mark Tivey, Group Captain Bill, thank you for being on Inside Air.
Thanks very much for having us.
Thanks very much, Peter. Cheers.
I'm Corporal Victoria Andrews with Reheat for InsideAIR. An RAF rivet joint, the RAF's premier signals intelligence aircraft, has been deployed on a reconnaissance mission over the Black Sea, monitoring Russian naval activity, as well as the movement of air defence systems and military communications along occupied territories in Crimea and southern Ukraine. The sortie was part of the UK's ongoing efforts to provide intelligence support to Ukraine and NATO allies. Personnel from 51 Squadron RAF Regiment have deployed to Norway's Arctic Circle to continue the development of the Combat Readiness Forces Arctic Warfare capability. Exercise Nordic Cheetah and Exercise Joint Viking saw 10,000 troops from 7 nations, including Canada, Finland, Germany, the Netherlands and the USA, exercise alongside each other. Operating in temperatures as low as minus 15 degrees Celsius, the squadron trained in essential cold weather survival techniques, including shelter construction, fire starting and ice-breaking drills. This deployment underscores the RAF Regiment's commitment to developing Arctic expertise. Next, an all-female A400M Atlas crew from RAF Bryce Norton have taken part in a historic flypast alongside a Prefect T1 and Eurofighter Typhoon. The flypast marked the unveiling of the Women in War exhibition at the Memorial Spire. And John Paddy Hemingway, the last surviving pilot of the Battle of Britain, has passed away at the age of 105. He played a crucial role defending the United Kingdom against Nazi oppression during the summer of 1940. On July 1st, 1941, he was awarded the Distinguished Flying Cross, and in September of that year, he was mentioned in dispatches. That's Reheat on InsideAIR.
Thanks, Victoria. And now it's time to find out who's under the hat with Ben.
I'm AS1 Ben Russell, and this is Under the Hat, where we get to know an aviator in less than a minute. Name you're known by.
Flight Sergeant Crystal Brown.
What's your profession?
I'm a people specialist and I'm based at HQ Air Command.
What's the best thing about your job?
The variety. So it's never ever the same from day to day, and the fact that I get to assist with policy that affects the people specialist for the Air Force.
Hardest part of your job?
In my role, I work from home, which is a necessity because of my family circumstance, but I really miss being in an office with people day to day. That's just me personally.
Best location you've served?
Probably RAF Gibraltar. So I did a tour there when I was a corporal, and it was 3 years as a PA, which I absolutely loved, and it was in Gibraltar.
What bit of luxury kit do you never deploy without?
Sounds a bit sad, but I would never deploy without my phone, because my phone is the way that I can contact my family, so my husband and my children.
And what's your proudest moment in the RAF?
I'm really lucky. I've had a fair few, but I think whilst I didn't recognise it at the time, I did a tour in Afghanistan where I acted as the Casualty and Compassionate SCN for Task Force Helmand out there, and the work that I did there and helped basically when people were in the worst circumstances is probably my proudest moment, if that makes sense.
Thank you, Flight Sergeant Brown, for being the latest aviator to take part in Under the Hat.
So that's it for another episode of Inside Air. Please do us a favour, give us a review, subscribe via your favourite podcast app, and join us again soon.
You've been listening to Inside Air, a behind-the-wire view of the Royal Air Force, its people, technology and operations. If you're serving in the RAF and have a story for us, please speak to your unit media and communications officer. Inside Air is written and produced for the Royal Air Force by RAF Media Reserves.